video, we'll explain section 7.1 in MAT095 on the rectangular coordinate system. The rectangular coordinate system consists of a horizontal number line, so going from left to right, that is our x-axis, and a vertical number line going up and down, that is called our y-axis. You'll notice that the numbers above the intersection, also this is called the origin, are positive, and so are the numbers to the right. The numbers going down are negative, and the numbers going to the left are negative. These two lines intersecting also create 4 sections. These are called quadrants. Quadrant 1, 2, 3, and 4. We can graph points in the coordinate system. Those points are also called ordered pairs. They begin with the x, comma, followed by a y in parentheses. Each point tells us which direction to go on the x-axis first, whether it's a positive or negative number, and then second number tells us whether to go up or down on the y-axis, whether that is a positive or negative number. And where we end up is where we create a point on that grid. So for example, the ordered pair 3, negative 4, start at your center, start at the origin, go to 3, it's a positive 3, so I'll go over to positive 3. Now go find negative 4 on the y-axis, so that's negative means I'm going down to negative 4, and where I end is where my point is. Here are 3 other example points that have been plotted on the number line. You'll notice that if one of our numbers is 0, it means we are not moving up, down, left, or right. So for this example, the y is 0. That means we're not going up or down anywhere, so the point is actually on the number line on the x-axis. If our first coordinate was 0, x, that would mean our point would end up on the y-axis. Write the coordinates of each point plotted in the graph. So for given points on a graph, we are able to find those coordinates by first figuring out, am I going left or right? That's my x-axis. Is it positive or negative? And then the second number, how far up or down am I going? So to get to B, start at the center, go over 2 points to the right. So positive 2 is my first number, and I have to go up 2 points. So 2, 2 would give me the coordinate for B. And we can continue the same strategy for finding our other points. A linear equation in 2 variables is an equation that can be written in the form ax plus by equals c, where a, b, and c are real numbers, but a and b are not both 0. A solution to a linear equation is an ordered pair that makes the equation a true mathematical statement. So we're talking about graphing lines. Now we want to know, is the point 2, 1 a solution to the equation? So if this is an equation of a line, is the point 2, 1 on that line? If it's graphed, would I see 2, 1 going through the line? So what we can do is, the first number is an x, the second number is a y, replace your x with a 2, the y with a 1, and solve. Do we end up with a solution that is true? 5 equals 5 is true. So that means that, yes, this is a point that would be on the line if we graphed the line, the equation 2x plus y equals 5. Here's another example. We want to know, is this point a solution to the line, to this equation? Replace x and y with the values. We get 4 equals 4, so yes, it is. Here's another example. Is negative 1, 5 a solution? We'll replace x with negative 1, y with 5, and we can see, would that work? There are many ordered pairs that are solutions, so remember, we can get more than one solution for equations such as this, right? -1 plus 5 does equal 4, but so does 0 plus 4. So does 3 plus 1. So we could choose any two numbers to add together to equal 4 and check them out to see if they would work, if they would be part of the line. 2 plus 2 also equals 4. So yes, that would work too. So with this, we can also find missing coordinates to complete an ordered pair for an equation. 6y equals 6x plus 5. So 2 comma what number would work? And so if we only know the x value, well, that's fine. That's all we need because we can replace x with 2 and solve for y. If we know the y value, we can replace y with that value and solve for x. And that completes section 7.1.